Students, this question was asked in the year 1998 from chapter 4 of class 11, that is from the chapter Laws of Motion. A 5000 kg rocket is set for vertical firing. The exhaust speed is 800 meter per second. To give an initial upward acceleration of 20 meter per second square, the amount of gas ejected per second to supply the needed thrust will be how much, students, when g is given 10 meter per second square. You see, student, the upward acceleration is 20 meter per second square. Okay, student, and the mass of the rocket is 5000 kg. So, student, the rocket will go this way, and that will have acceleration. How much, student? That will have acceleration 20 meter per second square. When the rocket will have 20 meter per second square, student, you know the acceleration of gravity will act in this way with 10 meter per second square. Okay, so the thrust have to be such so that this will balance the downward acceleration of 10 meter per second square and give an upward acceleration of 20 meter per second square, students. So the thrust T will be equal to m into g plus a. Okay, student, because the upward acceleration must be g plus a. If it will be 30 meter per second square, 10 plus 20, so it will minus the 10 meter per second square of acceleration due to gravity, and the net upward acceleration will be 20 meter per second square. So this will be, the upward thrust will be g plus a. And what is mass, student? Mass is given 5000 kg into, this is 10 plus 20 meter per second square. So this becomes, student, 5000 into 30. Okay, students, so this becomes 5 into 3, 15 into 10 to the power 4 Newton. Okay, student, the thrust is this much. So this thrust, the question is the amount of gas ejected per second. Okay, student, the amount of gas ejected per second. That means what is our, student? Asked question has asked what is dm by dt. We know the force here, and what is the relationship between the force and this dm by dt, student? We know force is equal to dp by dt, the time derivative of momentum. And what is momentum, students? Momentum is the quantity of motion contained in a body, and mathematically P is equal to mv. So this is d by dt of mv, the momentum. So, student, this becomes, according to chain rule, there are two physical quantities here, mass and velocity. So this will be dm by dt into v, the velocity, plus v plus m into dv by dt. But you see, the velocity is given. What is the velocity? 20 meter per no, this is the velocity, 800 meter per second, student, speed or the velocity. So, student, it is a constant quantity, the speed. So dv by dt is 0, and so this second term becomes, student, 0, and the force or the thrust is dm by dt v. So this one is dm by dt into v. So, student, what will be dm by dt? Then dm by dt will obviously this amount, the thrust by v, or what is v? V is, student, given how much? 800 meter per second. 800 meter per second. 800 meter per second. So this becomes, student, these two are cancelled here. This becomes 10 to the power 2, and 15 by 8 means 15. Let us divide 15 by 8. This will become 1, 8, and this becomes 70. So this becomes 8 into 8. This becomes 64, and 60, 8 into 7. This becomes 56, and 4, and so on. This becomes 1.87, and this is 40, and 8 into 5 means 40. So, student, 15 by 8 means 1.875. Let us write here 1.875 into how much? 10 to the power 2 meter Newton by meter per second. That is, student, kg per second. Okay, this becomes then 187.5 kg per second will be the amount of gas ejected per second. So student, in 1 second 187.5 kg gas has to be adjusted to give an initial upward thrust of 20 meter per second square, balancing the downward gravitational pull of 10 meter per second square. So student, this option B is correct for this question.